Hi, welcome to this video. Today's video we are going to evaluate this integral 1 over product of x plus k, the k from 0 to n. Let's put f of x equal 1 over product, let's expand this one, x factor x plus 1, x plus 2, so on, until you get the last term x plus n. If you want to take a try, just pause this video. When you're ready, come back to see how to solve this problem. Okay, let's begin now. This one is a product on the bottom. When you see the product on the bottom of fraction, this one right away you're gonna go to into the decomposition form. What the decomposition form means? Transfer product to the addition terms. So that's mean you put a0, you split every individual terms separately, so it gives you multiple terms. So a0 over x, that's why what's given us here, a0 over x plus a1 over x plus 1 plus a2 over x plus 2 plus a3 over x plus 3 and so on until you get the last two terms, which are a n minus 1 over x plus n minus 1 plus the last term, which is a n over x plus n, right? So these fractions, in order to find those terms a0, a1, and it will get an, it seems hard, but in fact it's not hard, because we have just simple fraction. If you take a look at the denominator, you see the numbers going up gradually as harmonic series. You see, x from x to x plus 1, from x plus 1 to x plus 2, from x plus 2 to x plus 3, and so on until you get the last two terms and x plus n. So this one easier to evaluate, to find these numbers a0 and a1. But before we begin evaluating the result we found in the first term, we have to compare it with the second term and the third term and so on until you get the last term. So let's begin with the first term, what we are going to find. So let's calculate the first term. Imagine just you have only this term in this integral. If you have only two terms integral, it will be easier, and that will be easier to find this a0 and a1. But remember, the number 1 has to be on the top. For the whole thing has to be 1. On the bottom of this integral, which is denominator, it has to be the product of all these number terms, x plus 1, x plus 2, as you see here. Okay, let's begin with the first one. a0 over x plus a1 over x plus 1 is giving us the product of x and x plus 1. Let's multiply the first one, this a0 and x plus 1, which is a0 plus a1, the whole thing multiplied by x, plus the little one a0. So this one, it has to go to 0. This one has to get to 1 in order to get 1 on the top, right? That's the purpose, how to get the 1 on the top. So this one, it gives us, okay, let's put it here, a0 plus a1 equals 0, a0 equal 1. So let's log in here. So that's mean a0 equal 1 and a1 equal minus 1, right? Okay, let's log in here. So a0, it become 1 over x minus 1 over x plus 1, right? This is what we find, the a0 equal 1 and a1 equal this one. Let's go to the second term. The second term, which is a2 over x plus 2 plus a3 over x plus 3. You will find the same thing. So 1 over x plus 2 minus 1 over x plus 3. If you multiply the product of x plus 2 and x plus 3, they're going to give you the number 1 on the top. Okay, so let's go to the last two terms. This one is the same thing. We are going to find an minus 1 over x plus n minus 1 plus an over x plus n. You will find 1 over x plus n minus 1 minus 1 over x plus n. So every single two terms, the first two terms is repeating like the same as the first one. Repeat this, you will find another second one, it will be the same thing, third one will be the same thing, so until you get the last one. So they are going gradually, and the numbers keep repeating. Number 1 on the top, and then the bottom, it has to be the products. Okay, so let's rewrite this one again in terms of products. Okay, let's do this one now. Let's clean the board now, and then rewrite our fraction clearly. Okay, so let's do it. F of x equal 1 over x minus 1 over x plus 1. This is two first terms. The second terms should be 1 over x plus 2 minus 1 x plus 3, and so on until you get the last two terms, 1 over x plus n minus 1 minus 1 over x plus n. Let's integrate this one now. Now it will be easier to integrate because we have separate fractions. Every single fraction, you know, it has the number 1 on the top, which we already found on all the numbers a0, a1, a2, so on, because until you get the en term. Okay, so let's integrate our integral. Our integral become dx over x minus dx over x plus 1 plus dx over x plus 2 minus dx over x plus 3, and so on until you get the last two terms, dx over x plus n minus 1 plus dx over x plus n, right? So this is a natural log. Okay, this is very clear. This is natural log of x. Don't forget the absolute value for each term, because the natural log has to be positive. Okay, minus natural log of x plus 1 plus natural log of x plus 2 plus natural log has to be the negative sign here, x plus 3, and so on until you get the last two terms, natural log of x plus n minus 1 plus the last one, natural log of x plus n. All right, if you take a look again here, you see the first term is an even number, the second one is an even number, the third one is even number, the third one is odd number, and so on. So whatever is even, it has the positive sign. Whatever is an odd term is a negative sign. All right, so let's put it in this one in this form. Natural log of x over x plus 1. We are applying this rule. Natural log of a over b equal natural log of a minus natural log of b. We have another one, natural log of a1, a2, and so on equal the sum of natural log of ak k from 1 n. The last one, natural log of a and n power equal n natural log of an. So we have to keep in mind, we have to know this one, the logarithm rules. Okay, let's do it here. So this one become natural log of this one over this one, x plus 2 over x plus 3, and so on until you get the last two terms, x plus n minus 1 over x plus n, right? Let's put this one as a product inside, because we have applying this one, the second one here, which is natural log of x plus 1, x plus 2, x plus 3, and so on, when you get the x plus n minus 1 over x plus n. Don't forget the constant, because we have indefinite integral. There is a difference between indefinite integral and definite integral. The definite integral is a value, has a value, but in the indefinite integral has a function, is an original function. Now we are looking for the original function, okay, of this integral now. So this one, at the same time, equal, this is a product of x plus 2k over x plus 2k plus 1, k from 0 to n, right? Let's rewrite down this one again on the top to make it very clear, okay, and accurate. The constant here. So our integral will become natural log of, okay, the product of x plus 2k over x plus 2k plus 1, k from 0 to n with absolute value, right, plus constant c, which is, we can bring this one product outside. Yes, we can do it. The product becomes sum sign outside. So this one become the sum. We are applying these rules. This is a product equal sum of, okay. So this one become this one natural log with absolute value, because we don't know the sign of this term, okay. It may be positive, it may be negative, we don't know yet, because we don't have any condition said that. So this one has to put the absolute value inside of logarithm, okay. So this one, x plus 2k over x plus 2k plus 1 from k from 0 to n plus c. This one we can write it down again this way, natural log of, we're gonna add number 1 here and subtract number 1 again here. So that's mean to put this one 1 minus 1 over x plus 2k plus 1, okay, plus constant, the k from 0 to n. This is our I integral. I think everything is clear. Thank you for watching. I see you in next video. Bye.